Okay, the Pauli exclusion principle says no two electrons have the same set of 4 quantum numbers. N, L, M, and M sub s. Each electron has its own set of 4 quantum numbers. N, L, M, and M sub s. Well, how do you define that? Okay, let's say we take oxygen just in general and write the configuration. That's a helium core, 2s2, 2px, py, pz, 211. Now this you should recognize from what we just talked about. But what are we showing here in the valence level out here? I'm not even talking about the 1s2 in here, but I could put it in there. That's a 1s2, so that's your core structure right there. But what are we looking at here? We're looking at 8 individual electrons. This one, let's start in the core and work out to the last electron. So we start in, what did we do? We got 1 electron in the 1s orbital. So that's a 1s1 electron. Okay? And then we put the next one in. The second electron is a 1s2 electron. That super 2 means there are 2 electrons there, obviously. Here you go to the second energy level, S1, and then you have a 2s2. So there are 2 electrons there. But that's 2 superscript, and this designation means we're talking about the second electron in. Then you have a 2p. Move this up. 2px, and you have a 2py and 2pz. And then we put 1 electron in each one of those. 1, 1, and 1. Those are your first electrons in. Then you come back and you parallel it. 2px2, that's the second one. You've got, make that a little smaller. You got 1, 2, 3, 4, 5, 6, 7, 8 electrons in L, M, and M sub s. Every one of them have a different set of those quantum numbers. What I'm trying to teach you. How do you tell what they are? If we take, let's see, let's take this one right here. What are the 4 quantum numbers for that? 2px1. This is your N value, the number in the front. P is your L value. X is your M value. And who's in first? Who's on first? There it is. So when you understand that I'm talking about an individual electron, now you can say N, L, M, and M sub s. The notations that I'm showing you define that. So if I'm working with this one, and kind of the N, L, M sub s for this one is a 2. All right, p orbital. Look in this handout that I gave you. See, S, P, D, and F. S, P, D, and F. S orbitals have a 0 value. 1 for P, 2 for D, and 3 for F. If I'm talking about a p orbital, then I'm talking about putting the L quantum number here as a 1. That's what the designation is. Now, which orientation? I'm in a py position. That's the one in the middle. I'm going to make that y. One in the middle, that's a 0. So if I'm working at py, I'm at 0 on that orientation. And if it's the first electron in, it's a +1/2. There are your 4 quantum numbers. Now, if you want to do the first one up here, it has a 2. X is is also a 1. The orientation is a -1. It's the first one in +1/2. See, these 2 are different. No 2 electrons have the same set of 4. Come down here to PZ1. Well, it's 2. And it's still a 1 or shape. The second one is a shape. And the third one is Z, 0 +1. And it's the first one in, it's +1/2. See, that is for that one. Now, if you come down here to px, you're starting to parallel now, and you're starting to pair them. It's still a 2 and a 1. This is your ring 2, second ring. It's a p orbital. It's an x, px, that's a -1, but it's the second, comma, it's the second electron in, -1/2. So if it's a 2 in that expansion right here, that's a -1/2. If there's a 1 there, well, here we are up here. There's a 1 up here, that's a +1/2. So these are different by the spin quantum number. You can go on up here. How about this one? Well, it's a 2. What's the shape of S? That's 0. That's your L quantum number. It doesn't have an orientation, so it's always 0, one orientation. And then the second one ends a -1/2. Here's this orientation, this electron, 2, and it's 0. It's also 0, but it's a +1/2 going into that one. Here is a first energy level, 0, 0, -1/2. There are your 4 quantum numbers. Here is a 1, 0, 0, +1/2. So when I say no 2 electrons have the same set of 4 quantum numbers, that's what this means. We're talking about individual electrons that remains separated from any other electron because of the Pauli exclusion principle, like that. Now, electrons in any element are the same as electrons in any other element. The quantum numbers are only defined in terms of where that electron is in the electron configuration. So you have to define where that electron is in the electron configuration before you can put the numbers down. But an electron in hafnium is the same as an electron in boron, whatever. It's only in the energy content of the electron that separates one from the other. Okay, that gets us through most of that. Got some curveballs to throw you. Okay, so these will show up on exam. What's wrong with that?
Oh, you didn't fill the rest of the thingies.
Well, this isn't, you can't parallel, you can't match them. You have to go parallel spins before you can't have 2 parallel spins of the same suborbital.
Yeah.
Plus, that would have to pair if it was going to be there, but it's not going to do that either. It's going to go over here.
Yeah.
Okay?
That's what I said, but less fancy.
What's wrong with that one?
That's too many.
Too many electrons in the suborbital structure. Those pop up on there.
It's wrong. That's just wrong. False. Go on.
What's wrong with that one?
The D. There's no D.
There's no d orbital in that second, so be careful. 1, 2, 3, 4. You got 1, then 2, then 3, 4. So if you could wind up with a question that says that you have a 3f orbital,
It's wrong.
well, does it step down to a 3f? No, it's 4f is the first one up. So you have to be in the 4th energy level. That's right. You look at your scheme. So it's little questions like that will pop up on the exam. Look at your practice exams online. If you haven't found them yet, let me know. I'll send you the link. But that's the best study guide that I can give you, is to be able to work at that level, and you'll do fine with the one coming up on Thursday. Okay, we made a lot of progress today, and electron configurations and the modern quantum model and so forth. Tomorrow, I'm going to get into chemical bonding and talk about ionic and molecular bonding. So y'all have a pleasant evening, and I will give you a couple of quizzes tomorrow.